I'm Senator Thaxton, and this is my homework 5 for MTRE4100 instruments and controls. So the object for this is we have to create an auto mains failure, which uses a backup diesel generator to ensure that main power supply remains active and ensuring stable output. We have to do traffic light control. We have to have red, yellow, green lights for an intersection. I used horizontal and vertical in mine, and we have to, time it and incorporate pedestrian signals, emergency vehicle detection, and synchronization with the integrated systems, which you see down here. This is just saying that when power failure is detected, the traffic light system should switch to a safe mode. It says adjust the timing and sequence in traffic lights based on availability of backup generator power. And the third one is we have to use a flow measurement, which in this one we're using a cars per light measurement. So in the amount of time that the light is green, we want to measure how many cars flow through the intersection. And you can see down here, this is hopefully everything that I have in my video. If not, I guess we'll see. So, see, we've got the ComGR running. It's our HMI that we've created. We have a power control box that's kind of expanded. This is not to scale at all. But we have our main power. We have our diesel generator, indicators for the main contactor and DG contactor, indicators when the diesel generator will start and when the diesel generator will stop. We also have timers to show the values that we've preset. We also have our red, yellow, green for horizontal and for vertical. We even have an emergency vehicle sensor for the horizontal and the vertical, and pedestrian crosswalks that you can see. Also, this black bar right here is used to simulate one of those cords that you may see run across the road. I'm not sure if everybody's seen that. I have out where I live. There's usually just a box sitting off to the side that measures when a car runs over the little circular cord. So we have our flow in cars per light, and that's our traffic counter, which will show us the timing sequences we have, once again, for our green, our yellow, and our red for the horizontal and the vertical. Now, here you can see we've implemented our auto mains failure. It's pretty much just using straightforward from the lecture video. We have our on power, our start delay DG T0 with a 20-second delay. When our DG starts on, we have we're resetting our timer 2 and timer 3, and we're starting our DGY, DGY2. Here we have the start timer T1 for DG contactor. So when the DG, or when X1 is activated, we have a 5-second delay so that the generator can get up to power, I guess, and then our contactor T1 after 5 seconds will turn on the power from the diesel generator. Here we have the turn off DG contactor when main comes back. So when our main power cuts back on, we have a 2-second delay to reset our T1 right here, which will reset this and turn off the DG contactor. And here's our start main contactor, our delay main contact with our T2, which is right here, and the stop delay DG before finally we have power from our main contactor. And this T3 has a 5-second counter, which is why we wrote 50. And once this T3 is activated, then our diesel generator will stop. Next, we move down into the traffic control system that we have created. This is pretty much, again, straight from the lecture with a couple modifications that I've made to incorporate some of the additional requirements of this homework. In order so that this homework doesn't, the video doesn't last forever, I have reduced the time for our green and increased the time a little bit for our yellow. So in essence, we have to 25-second 25-second cycle for our horizontal, then a 25-second cycle for our vertical. So hopefully we don't have to sit here for 10 minutes waiting on this to count out. This is a modification that I made. Save on-off state for traffic light, implement emergency vehicle detection. So the idea that I had was when our main contactor cuts on, we will save that in M7, kind of like how we did in one of the previous exercises, and use M7 to turn on our counter and our incremental drum sequencer. But I have implemented these two contacts, X2 and X3, for my emergency signal so that they can cut off the power to the counter and to the sequencer, so that I can have access to these down here for the emergency vehicle detection. And then once the sensor from either emergency vehicle detector turns back off, we restore main power, or we restore power to our counter and our sequencer, which continues this sequence right here. And as you can see, our networks for our horizontal look sort of similar with a couple modifications. The first one is my green light horizontal. So when M1, which was up here, well, this will be moved into M1 here. When that comes active, our green horizontal is on. Or if our emergency signal H horizontal X2 is activated and the main contactor is active, green horizontal will turn on. I had to include this in here so that this did not interfere with the power failure state for the yellow horizontal, which I'll tell you about in a second. And last, we have our green flash with our clock pulse, which is the same one we used here to provide a 1-second counter for our traffic lights. So down here, when our drum sequencer gets to D3, we'll activate M3, which will turn yellow on. And I also have the DG contactor here, so that when the backup generator is turned on, we have a 1-second clock pulse tied into the yellow light, so that when there's a power loss and our DG contactor is running, the lights in both directions will flash yellow to indicate that people should be cautious when going through the intersection. And of course, our red light horizontal with emergency stop vehicle is set up pretty much the same. We want our red horizontal on whenever any of our vertical green flash, or yellow are on, but we also want red horizontal when our emergency signal from our vehicle is detected coming from the vertical direction. And I added the main contactor here so that the emergency signal could only work when the main power is active, so it's kind of, I guess, saves a little bit of power if there's a power outage, because the yellow lights will be flashing and everybody should be cautious anyway and move in a somewhat safe manner to begin with. Then we come down and we have our green light vertical, which you can see that the green light vertical is set up pretty much the way the green light horizontal was, where if our M4 is active, our green is on, or if our emergency signal is active and our main contactor is active, then the green is on. And then we have our green flash with our 1 second pulse. Then we have the pedestrian vertical. We also had a pedestrian horizontal over there. I don't think I explained it. I might have skipped it, but it's basically the same thing. Whenever the green is on, we activate our pedestrian, whether it's vertical or horizontal, depending on green horizontal or green vertical. And our walk signal from our pedestrian signal will be active. But if our emergency signal is on for our vehicle, then we want to stop the pedestrian crosswalk in all directions, because if our emergency vehicle is traveling vertically or upwards the screen, we don't know if they're going to go left, if they're going to go right, if they're going to continue going straight. So we just want to stop everybody from walking in the cross section. And then once again, our yellow light vertical, when our M6 is activated and the drum sequencer, our yellow light will be on. We also have the DG contactor and our 1 second pulse here, so that the vertical is also blinking yellow with the horizontal. Red light vertical, same as red light horizontal. When anything in our horizontal, whether it's our green flash, or yellow, horizontal is activated, our red vertical will be on. The red vertical will also be on when our horizontal emergency vehicle signal is X2 is activated. So whenever that sensor is activated and the main contactor is on, then our red will be on as well. And lastly, down here we have our flow rate counter. So X4, this was the little black strip that I'd laid across the road that was supposed to indicate the little cord that I've seen cars run over, and I guess they count traffic or speed or something, I'm not sure. But we want to count the number of pulses. And when we count the number of pulses, we're going to store that into C7. And, we probably can't get up to 100, but, we want to have a pretty big value here, even though we're only using a 2 second counter, just in case. Then we activate our timer, like we did in the video exercise. T4 is the timer that I've used for this, and it's a 2 second timer, so we put 20. And then this is where we move our pulses and reset C1 and T4, so that every 2 seconds, our timer will reset and our counter will reset, so we can kind of, get readings and take the average of those readings. And then lastly, we get down to the multiply. So what we're going to do is we're going to register the number of pulses from the car sensor. Then we're going to store those pulses into D8. We're going to multiply D8 by 10. Why are we multiplying by 10? Well, if we scroll back up to here, we can see that our green H and our green flash for horizontal, we have 15 and 5 second intervals for the two lights. So 15 plus 5 is 20. We're taking a 2 second timer, multiply it by 10, and that gives us our 20 seconds for our total green light. And, because we really don't want people to be trying to run yellow lights. I mean, it does happen occasionally, but we're not going to include this in our data because we only want to know how many cars are passing per green light. So scrolling back down to our division, we take our number of pulses, we multiply them by 10, and we store them in D12. Then we convert here. In this one, when we multiplied by 10, we were doing pulses per light or green light. total. And then down here, we convert into cars per light or cars per green light. So the way we figure is that when we run over the cable, we have front tires and we have back tires, whether it's a motorcycle or a bicycle or a car, the front tires are going to hit it. And for our simulation, we're going to simulate that as one pulse, and then the back tires are going to hit it, and we're going to simulate that as two pulses. So we take the total number of pulses and divide that by 2, and that tells us how many cars. I need to change that. But anyway, now that we went over everything, let's compile. Oh, 0 errors, 0 warnings. Okay, that's good. Now we download to our PLC. Turn our online on. It's the very MP. Run. Switch back over here. Compile all. We see there's no errors. Compilation successful. Offline simulation. So we turn our main contactor on. Contactor's on. We see that we are here on M1. Our green horizontal is working. Our pedestrian H is working. Our red vertical is working. And we just wait 15 seconds and we should transfer from now on M2, where we can see our horizontal working. We're on yellow. And as soon as we turn green here, we can start clicking. Something's not right. I'll have to adjust that. Maybe we should have divided by 4. But anyway, can't really change that now. I mean, I guess I could, but let's stop this. So if each click of this bar is 2, then that's 2 for the front tires and 2 for the back tires, which means that our program should divide by 4. Try that. Pull our window back up. Main contactor's on. DG stop, DG off, contactor off. Our counter should go to 15. Here. Switch over to flashing horizontal. We also have our crosswalk flashing. Then when it turns yellow, our crosswalk says don't walk. This will go to green, bam, 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 bam. Well, that's not right. Anyway, let's test the other features of this thing. So we can see here, we got a red light, emergency vehicles coming, changes green, goes red, vehicle gone, normal operation. This next one, I could not get it to work. When you click the emergency vehicle, my best guesstimation is that because we're cutting off power here and the counter and the drum sequencer are not receiving power, they reset when this goes off, because once the emergency signal goes off right here, then this will come back on, this will come back on, this will come back on, these will start over, this will start at state one. I try to move command to get it to go to this position, but I could not figure out how to make it work. So it just goes back to the first state with green horizontal, as you can see. But say, for instance, let's say that the main power does go off. Once our power is off, obviously nothing's working. DG start, generator starts, contactor hits, traffic lights are flashing yellow, and we have don't walk and don't walk, because, if power's out, then probably shouldn't be walking around anyway. But this is my video. Sorry I couldn't figure out the emergency vehicle thing, but sometimes this stuff happens. See you all next time.